are you, my friends? In this video, I'm presenting basic math terms, part 22, about trigonometric functions. These terms are coming from lectures 11, 13, and 15 of the pre-calculus course. Please, you can refer to the other parts in basic math terms in this playlist. So the terms here are sine function, cosine function, tangent, cotangent, secant, and cosecant functions. Terminal side, reference angle, argument, amplitude, period, phase shift, and basic trigonometric identities. Now we start by defining the 6 trigonometric functions of angles. We can take theta in any quadrant. Here I took it in quadrant 2. See, theta lies in quadrant 2. It can be in quadrant 1 or quadrant 3 or quadrant 4. So we define the sine function. Sine of theta will be y over r. See, this is the angle now in quadrant 2. So the sine of that angle will be the y divided by the r. Or you can say the opposite divided by the hypotenuse. Cosine of the theta will be x over r. See this x over r. It will be the adjacent divided by hypotenuse. Now r will be the square root of x squared plus y squared. See, when you square the x, you square the y, you add, r always positive number. X can be positive or negative, y can be positive or negative, but r is always positive number. Now you can define tan theta as y over x. You can define cotan of theta x over y, and you can see the relationship here between tan theta and cotan theta. They are reciprocals. So if you know tan theta, let's say 2 over 7, cotan of theta will be 7 over 2. Secant of theta r over x and cosecant of theta r over y. Secant is related to the cosine. You see, cosine of theta x over r and the secant of theta r over x, which is the reciprocal. Also, cosecant of theta is the reciprocal of sine of theta. Now the reference angle, this is the definition of a reference angle. It is the positive acute angle. So it is very small angle between 0 and 90 made by the terminal side. The terminal side where the angle ends. Let's look here. Look here, the angle theta itself is in quadrant 2. So the blue line here, this one is the terminal side. And this is the x-axis. Okay, all of this will be the x-axis. So this is theta here. So this one, the small angle here between the blue line, the terminal side, and this x-axis, this will be reference angle. So it will be 180 minus the theta, or pi minus theta in radians, and this is in degrees. If the angle lies in quadrant 1, the reference angle is the same as the angle itself, like 40, 42, 57, 61, etc. If the angle lies in quadrant 3, just imagine here, we have a theta like this in quadrant 3, like 200. If you need this theta prime or theta dash, both will be reference. It will be the angle itself minus 180. This is the way to find it. If the angle lies in quadrant 4 and you need the reference angle, you take 360 minus the theta in degrees, and in radians it will be 2 pi minus theta. And you will use this reference in many questions. So this is what we call reference angle. Argument is very important issue here. I put 6 examples to make sure you understand the argument correctly. If you have a function like this, all of these are trigonometric functions. 10 sine 8x plus pi, and you need the argument because when you graph it and you need other things, you need the argument, the correct, I will call it correct argument, so don't be mistaken. So what is the argument here? It's 8x. It's all the expression after the function. See, like this one here, you have a bracket, minus 8 cosine bracket, you have a bracket, 5x minus pi. All this expression will be the argument. But in the first one here, there is no bracket. 10 sine of 8x plus pi. So pi, we can put it at the beginning. This is shifting upward, pi units. So the argument in the first one, only 8x. Continue the same idea here, number 3. You have 2 tan of this one here, all this, bracket plus 4. So this is the argument here, pi over 2 plus 8x. So all this slide is telling you how to get the correct argument, because you will use this argument in many questions. Here we have 2 minus cotan half 10x minus 7 pi. Where is the argument? Everything after the cotan. See? So it will be half is included in the argument, times 10x. So it will be 5x there. Multiply by half, it will be minus 7 pi over 2. See, compare now 4 and 5. Here you have secant 3 and you have a bracket, then you have another plus 2. This plus 2 is not included in the argument. Only 3 times 2x, 6x, 3 times minus pi over 3 minus pi. This is the argument. And this 2 is shifting up. This is related to 12. You can add them if you like. And this one also just multiply the 4 times this one, you will get the argument. Okay. Trigonometric functions are periodic. The word periodic means when we graph them, they will be repeated every certain period. Now for the sine and cosine, the period is 2 pi. You can see here these simple rules here from coterminal angles. Sine of t plus 2 pi will be sine of t. Same for the cosine. So the period for sine and cosine, when you graph them, it will be 2 pi. The period for tan and the cotan is pi, because tan t plus pi will be tan of t, and cotan of t plus pi will be cotan of t. But the secant and cosecant, they have period of 2 pi. Now the last 2 lines here is the definition of a periodic in general. A function is periodic if there is a positive number p such that f of t plus p is equal f of t. See, this is the same t here. If you have a number p added to t, you will get the same as f of t for every t. Then this is a periodic function of period p. Amplitude, this is the definition, the formula, and the graph to see the idea of amplitude. So the amplitude, when you see the word amplitude, is half the difference between the maximum and the minimum. So if you have a graph, take the maximum value, see, let's call it max. Take the minimum value minus min. Divide by 2, you will get a number, we call it amplitude. It is the absolute value of A. A is the coefficient of the sine function here. So A can be positive, can be negative, can be fraction also. A itself, the coefficient. But when you see the amplitude, it's a positive number. It will be the absolute value of A if you know the function. If you have the graph, take the max minus the min, divide by 2. And max and min, always you can get them from the range or from the graph. The maximum is the highest value in the range, and the minimum is the smallest value in the range. Another way we can understand the amplitude, it is the height of the graph above and below a horizontal line that goes in the middle of the graph. So if you just imagine a line in the middle of the graph, this height here is the amplitude, and this height here is the amplitude. It's a positive number. This is the general sine function summary. Just to understand, if you need to graph it, you will go through 1, 2, 3, 4, and 5. You can find the range. You can find the phase shift. Phase shift is the B. This is like horizontal shifting. We have used that in many other functions and graph. A, as I mentioned, the coefficient of the sine here. K is the coefficient of the x. So it can be A sine K bracket x minus B, or you can multiply the K inside. So if you need the argument, we have mentioned before, it will be K bracket x minus B, or Kx minus Kb. That is the argument. X-intercept, let y is equal to 0. So you take the argument equals n pi. This is the range without vertical shifting, minus absolute value of A, absolute value of A. That means there is no number there, D. If you have a shifting with D, it will be D minus absolute value of A, D plus absolute value of A. This is the range of the sine, and also the cosine. The sine function is an odd function. Sine of minus x will be minus sine of x. The domain is all real numbers, and the range closed interval from -1 to 1 if you need the graph. This is the complete graph of the cosine function without any shifting. This is f of x is equal cosine of x. And the cosine, as we mentioned before, it's an even function. Cosine of minus x will be the same as cosine of the x, and it is symmetric with respect to the y-axis. See, the y-axis will divide the graph into two equal pieces. The domain is all real numbers like the sine, and the range closed interval from -1 to 1. This is without shifting, remember. The basic trigonometric identities, the reciprocal identities, cotan of theta 1 over tan of theta. So this is the reciprocal. We have 3 of them. Secant of theta 1 over cosine of theta. Cosecant of theta 1 over sine of theta. The quotient when you divide, tan of theta will be sine of theta divided by cosine of theta. Cotan of theta will be cosine of theta divided by sine of theta. And remember, tan theta and cotan theta are reciprocals. Pythagorean identities, sine squared of theta plus cosine squared of theta is 1. This is number 6 here. Number 7, 1 plus tan squared of theta will be secant squared of theta. And number 8, 1 plus cotan squared of theta, cosecant squared of theta. We can get 7 and 8 from number 6. So you take number 6 here and divide by cosine squared of theta on both sides. So divide this one, sine squared of theta, divide by cosine squared of theta, and divide this one by cosine squared of theta. Divide this one by cosine squared of theta. You will get number 7. Number 8, if you divide this one by sine squared of theta, divide this by sine squared of theta, and divide the one by sine squared of theta, you will get number 8. So we can derive number 7 and 8 from number 6. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.